Hello students, welcome to Eduxcite classes. Welcome to the Unwrapping of Paper 1 series. Today's session will discuss topic 3, that is your thermal physics. Okay, so it's a small request, please solve this worksheet. The PDF for the same is given in the description. You can find out and download the PDF. Solve all the questions and then check with the marking scheme available. If you have any doubt in any of the question, please watch this video for your further clarification. So without wasting time, let us start with the question number 1. So the question number 1 says two different objects which are in thermal contact with one another. The objects are at different temperature. The temperature of the two objects determined. Like let us say these are the two objects 1 and 2. Okay, so these are in thermal contact with one another, but they are at different temperature. Let us say this is T1, this is T2. Let us say T1 is greater than T2. So the temperature of the two objects determine what happens. So we know that when the two objects are kept in contact with certain difference in the temperature, the heat always flow from higher temperature region to a lower temperature region. That is the direction of the transfer of thermal energy, option C. Rest all are incorrect. Question number 2. The Kelvin temperature, that is the unit of SI unit of temperature. Okay, so this of measures of what? So we have discussed this, that this is the temperature is directly proportional or the measure of average kinetic energy of the molecules of an object. That is option D. Rest all are your incorrect option. Question number 3. Two bodies are brought in thermal contact with each other. No thermal energy transfers. Please mention there is no thermal energy transfer takes place between the, it may be deduced, therefore the bodies must have what? So whenever there is no thermal energy is transferring takes place, it means that both the bodies are at the same temperature, option C. Question number 4. Which of the two values of the temperature are equivalent to the nearest degree when measured in both the scale, that is your Kelvin and Celsius? So we know that the relation between the Kelvin and the Celsius is T plus 273. Okay, so T is measured in Celsius. So whosoever is following this relationship will be your correct answer. So I think 0 is not, it is has to be 273. Option D is incorrect. 40 degrees Celsius. So 40 plus 273 is, yes, 313. Option C. Rest all, it is incorrect. This is also incorrect. Okay. Question number 5. During an experiment, a solid is heated from 285 to 298. So that is the temperature difference. Which of the following gives the rise in temperature in degrees Celsius and the final temperature in degrees Celsius? Okay. So rise is the difference between 298 and 285, which is 13 degrees Celsius. So rise in temperature is 13 degree. So these are incorrect. Now in Celsius, again it cannot be so much because 298. So 298 minus 273 will give you the answer, that is 25 degrees Celsius. So the final temperature in Celsius, this is 25 degrees Celsius. Option B. Now question number 6, please pay attention. Many of the students have confusion about what do we mean by the term internal energy of a system. So internal energy of a system is nothing but the sum of average kinetic energy of the particle plus the potential energy of the molecules of the object or the substance. So internal energy is the sum of your potential as well as your kinetic. Now what do we mean by potential and kinetics? Please pay attention. Let us say this is a glass filled with water. So no apparent energy of the glass of water on a macroscopic level, but when we see the microscopic level, there are the particles. Okay, so the microscopic, each particles of the water molecules are having some random motion. So this is your average kinetic energy, whereas the molecules attractive forces are associated with the kinetic, and these all are having some bonds, attractive forces. Okay, so that is your potential energy. So the sum of this plus this is considered as your internal energy. Okay, so I hope now it is clear. Question number 7 again. A container holds 20 gram of neon and 8 gram of helium. The mass numbers are given. The question asks you the number of atoms. So guys, please remember, the number of atom is like how we measure or calculate. Okay, so for example, 1 mole, or you can say 1 mole is equivalent to the 20 gram of, because the mass number is 20, so 20 gram of neon is having Avogadro number. The number of molecules are equal to the Avogadro number, which is 6.00022 times raised to power 23 number of atoms. So this is the number of atoms in 20 gram. Why 20 gram? Because this is 1 mole. So 1 mole of any substance is equal to this much amount of atoms. So neon 1 mole is because this is 20 gram and the mass number is 20. So again, but for helium, when we say the mass is, so therefore 2 moles are there. Okay, so the number of atom will also be 2 times of 6.022 into 10 raised to power 23. Now if you take the ratio, the Avogadro number gets constant and you get 1:2. So 1:2, that is B 0.5. Okay, so this is how we measure the number of atoms. Now molar mass, this is again a confusing question for a student. Molar mass of the water is 18 gram. We have to find out the approximate number of the water molecules in a glass of water, guys. Okay, now we know that in a glass of water at least 200 gram of water will be there. So number of moles, you can say, is what? 200 divided by the molar mass 18. So it is roughly around, you can say, 10 times. Okay, and into 6.022 into 10 raised to power 23. So it is roughly around coming to 10 raised to power 24, or you can say the nearest answer is 10 raised to power 25. Okay, so this is how you can, because it is written already approximate. Now question number 9. The specific heat capacity of an object is defined as the thermal energy required to raise the temperature of what? Of unit mass of the object by 1 Kelvin. That is option D. This is the definition itself, and that you should be know, because it asked in your paper 2 as well. Now question number 10. A specific heat capacity of a metal block, okay, this is a metal block of mass m, is determined by placing a heated coil in its center, okay, as shown in the diagram. The block is heated for time t and the maximum temperature recorded is delta T. The ammeter and the voltmeter readings are I and V respectively, as shown in the diagram. Now how you will get the expression for the specific heat? So we know that specific heat is measured as Q equals to mc delta theta, that is the change in the temperature. Now specific heat capacity is C, so that can be written as Q upon mc. Now Q is the energy supplied. Now here energy supplied is to the heating coil, so that we can do is energy can be written as power into time, because power is energy per unit time. Okay, electrical energy. So electrical energy formula for power is V into I into T upon M into C. Okay, so this is your option A. So I hope you get the clear understanding. If you have any doubt in any of the option, how we get that, please comment below. I will try my level best to reply you back as early as possible. Now question number 11. The specific heat capacity C, again of a solid block of mass m, is determined by heating the block and measuring its temperature. The graph below shows the variation of temperature of the block with the thermal energy supplied, the gradient. Now again this is, you can see the temperature is continuously increasing. So the specific heat formula is Q equals to mc delta T. So the gradient is what? Delta T over Q. So delta T over Q is equals to 1 upon mc, rearranging this equation. So this is nothing but the gradient. So gradient is equals to 1 by mass times C, that is option D. Now question number 12. If you see, which of the following correctly shows the changes, if any, in the potential energy and in the kinetic energy of the molecules of a solid as it melts? So we know that when the solid is melting, there is no change. Okay, please remember, whenever there is a change in phase, there is no change in temperature takes place. If there is no change in temperature, means no change in kinetic energy, because they are directly proportional. So there will be no change in kinetic energy. So this and this gets wrong. Now we have to think whether the potential energy will increase or will stays the same. Now it becomes easy. Now you know that when the temperature is not changing, the supplied energy is required to increase the potential energy of the molecules or the system. So potential energy will be increased when there is a change in phase. Okay, so option B. Now similarly, question number 13 again is the similar type. It is asking you the same. When a substance is changes from solid to liquid at normal melting temperature, how the average kinetic energy and your average potential energy of the molecule differ. So again, there is a change in phase. So the average kinetic energy will be constant. So B and C are your incorrect option, and your potential energy will increase, option D. Now the specific latent heat of vaporization is greater than, so we know that vaporization is greater than your latent heat of fusion. This is because the only thing is, during the vaporization, that is converting phase from gas liquid to gas. Okay, so in that we can say the potential energy of the molecule is greater on boiling, when there is a change in phase from liquid to gas, as compared to that on melting. So option D is the right answer. Therefore more heat has to be supplied in order to overcome the gain in the potential energy of the liquid, in order to change its states from liquid to gas, as compared to from solid to liquid, where the potential energy is less. Okay, so option D is the right answer. Now question number 15. The specific latent heat of vaporization is this quantity of the energy required. Now latent heat is what? Is the amount of energy to convert a unit mass of liquid to vapor at a given temperature and pressure. Unit mass. So that is again the definition that should be remembered. Now question number 16. A graph is given. Okay, so the question is asking, in which region or regions of the graph must there be more than one phase of the substance present. Now we know that one or more than one phase is only when there is a change in phase change takes place, and phase change is identified when the temperature is constant. So in the given graph you can see the temperature is constant from x to y only. So option D is the right answer. Okay. Now question number 17, it is the direct question, which is not an assumption of a kinetic model of ideal gas. So you see the only B is not the option, sorry, B is not the assumption, rest all are your assumptions for your kinetic energy. So mean square speed of the molecule is proportional to your Kelvin temperature. This is the Boltzmann equation. Okay, this is based on Boltzmann, not the assumptions of your kinetic theory of gas. Now question number 18. When the gas is compressed rapidly by the piston, its temperature rises because the molecule of the gas. Now you can see here, if I rapidly compress the piston, there will be rise in the temperature, and this rise in the temperature is because of the gain in energy of the moving piston. Option D. If you see, collide with the walls of the container more frequently, that will increase the the pressure. Okay, collide with each other more frequently, again there will be pressure. Are squeezed close together, that will have no effect on the time. So only and only the temperature rises because of the gain in the energy. Whenever you see the temperature, it should always relate with the energy, and that energy is nothing but the majorly the kinetic energy. Now question number 19. The temperature of an ideal gas is reduced. Which one of the following statement is true? Okay, so if I reduce the temperature, the molecule collide with the walls of the container less frequently. Yes, if the temperature is reduced, then your kinetic energy also reduces. If the kinetic energy is reduced, then the rate of collision will be less. Okay. Rest all are the molecules collide with more frequently. No, it cannot be. The time of contact between the molecules and the wall is reduced. No, it will. How it will be reduced? The time of contact between the molecule is increased. No, these all are your incorrect options. If you have any doubt, just comment below. Question number 20 now. When a gas in a cylinder is compressed at constant temperature, again at a constant temperature, the pressure of the gas increases. Now at a constant temperature, when the gas in a cylinder is compressed, which of the following statement is which statement correctly explain the increase in pressure? Now you see, if the increase in pressure at a constant temperature, that is applicable. Let us read the statement. The rate at which the molecules collide with the piston increases. So if the rate of the molecules collision with the piston increases, definitely the pressure is going to increase, because pressure is what? Force per unit area. If the collisions, the rate of change of momentum is happening more, force is directly proportional to change in momentum over time. So if the momentum collisions are increasing, change in momentum is increasing, as a result force increases, as a result pressure increases. So option 1 supports the statement. Average speed of the molecule increases? No, because it is at a constant temperature, so there will be no increase in the average speed. The molecules collide with each other more often. So we cannot say like this, because at a constant temperature, if the pressure increases, volume decreases. Okay, so the molecules collide with each other more often. So we can say, but this will not increase the pressure. Okay, so it is not, it will happen, but it will not support the statement for the increase in pressure. Therefore only option 1 is correct, that is option A. Okay, now question number 21. The behavior of real gas with support. So it is at low density. Okay, now low density means at low density of a gas, the real gas behaves as your ideal gas. Okay, so at low pressure and large volume, definitely at low pressure and large volume, the density will be low and it will obey the ideal gas equation. Rest all are incorrect options. It's a direct question. Okay, just remember this. Now question number 22, the two identical boxes. Now identical means the volumes are the same. So volume of X is equals to volume of Y. So this is an ideal gas. So in box X there are n moles. So what we have to find is the ratio of PA. Now Px Vx equals to n x r is constant T. Okay, and Py Vy is equals to Ny R T is T by 3. Okay, and let us replace the value of n also. If this is n, then this is 2n, and Vx is equals to Vy. So taking the ratio Vx Vy is cancelled, this n and this get cancelled, R and R gets cancelled, 3 goes to the numerator, T and T gets cancelled. So Px by Py, simple mathematics, is 3 by 2. Option B is the right answer. Question number 23. So it's a direct, and this is the ideal gas equation, and represents what? And represent the number of mole of the gas. Question number 24. This is an ideal gas kept in a container of fixed volume. Now volume is fixed. Okay, there is no change in volume. At a temperature of 30 degrees Celsius and pressure is 6 atm. The gas is heated again at constant volume to a temperature 330. So at a constant temperature, I can say PV equals to nRT. So if at a constant temperature, these all are constant, so P by T ratio is constant. So I can say P1 by T1 is equals to P2 by T2. Just put up the value 6 by 30. Please convert this into Kelvin. So if you convert 273 plus 30, which is 303, equals to new pressure we have to find out. Temperature is, so this is 30603. So you can roughly say that P2 is 6 times of 603 divided by 303. Roughly it is 2. So 6 times 2 is 12. Option C is the right answer. Okay, roughly you can say, is about approximate. Now question number 25, if you look at the graph, the question is asking work done in compressing a gas from R to P. Okay, now when a gas is compressed from R to P, you can say the volume decreases and the work done is what? At a constant pressure, P times change in volume. Please remember this. I hope you know this. Work done equals to pressure times change in volume. Now pressure from R to P is 1 into 10 raised to power 5. Change in volume is from 5 to 2, that is 3 into 3 only. In meter cube only it is given. So no need to change into SI unit. Delta V is 3 meter cube. So this is 3 into 10 raised to power 5 joule. Option C is the right answer. Now question number 26, a diagram shows the variation of volume V with pressure P during one complete cycle of a heat engine. Okay, the work done is presented by the area. Now you can see that the work is doing in this is the closed cycle. Okay, so here the work is done by the graph A only, the shaded part. Okay, so this is option A. This is the only work done by the engine in one complete cycle. Question number 27, a sample of an ideal gas is held in an insulated container. There means no heat exchange can take place. That is your adiabatic change. No heat exchange. Adiabatic change means no heat exchange takes place from the system to the with the surrounding. So the graph below shows pressure and the change in volume from X to Y. Which of the following describes the work done and the change in internal energy? Now you can see from X to Y, the gas is compressed. Okay, so if the gas is compressed, means work is done on the gas, because the volume is decreasing. So whenever the volume is decreasing, make sure it means the work is done on the gas. Okay, so volume decreases means work done on the gas, and vice versa. It means if volume expansion takes place, it means work is done by the gas. So this is a very important significance of the term on the gas and by the gas. Okay, so this is the smallest or the easiest way to remember. If there is a compression, it means work is done on the gas to compress it, and it is expanding, it means gas has done the work to expand itself. Okay, so in this case X to Y, the work is done on the gas, and if the work is done on the gases, means the energy is gained by the gas, it means internal energy will get increased. Option A is the right answer. Now question number 28, if you see the graph is again for pressure versus volume, during which operation there are different P to Q, Q to R, R to S and S to P in one complete. Does the gas do external work? Again, the gas has to do work, it means it is expanding, and expanding means the volume increases, that is only from R to S. So option B is the right answer. Okay, so I hope you get a better understanding of this question number 28. Now question number 29, which of the following graph best shows the variation with Celsius temperature T and pressure? Now this is Celsius scale. Okay, so at a constant volume, we know that pressure is proportional to temperature. It means there is a straight line, so this is incorrect. Pressure cannot be 0 at a certain degree Celsius. This is again 0. Again here it is 0, pressure is 0 at 0 degree Celsius. No. There will be certain pressure of a gas at 0 degrees, because it is not Kelvin. Okay, 0 degree Kelvin is the absolute temperature, but 0 degree Celsius is 273 Kelvin. So this is also incorrect. Option A. It means there will be some initial pressure when the gas is at 0 degree Celsius. Okay. Now question number 30. The graph below shows the variation of absolute temperature of the pressure P of 1 mole of a ideal gas whose volume is V, R is the molar gas constant. Which of the following is the best interpretation of the intercept on the temperature axis and the gradient of the graph? Now if I complete this, okay, this will be something around like this only. Now if you see for this question, the intercept is again 0. You can see it is meeting at 0. So intercept is 0. So this and this gets cancelled. Now the gradient. So this is P by T. So PV equals to n RT. N is 1 because it is asking for 1 mole. And R and V are constant because it is given that this is happening at the constant volume. Okay. Or the volume is V, you can say. Let us say the volume is V. So N and R gets overlooked out. So P by T is R by V. Let us say R is a constant. Anyway, it is given in the option. So R by V is the ratio. Option B is the right answer. Okay. Now 31 and 32 is a very good question. Let the average translational kinetic, now this question is average translational kinetic energy at temperature T of a helium whose molar mass is given as K, and the average translational kinetic energy at the same temperature of neon would be. Now we know that, okay, the average kinetic energy is depending on temperature. If temperature is constant, it means kinetic energy will also be the same. So option C is the right answer. But now in question number 32, read the question carefully. Okay, so atomic mass of the helium is given, neon is given, both are monoatomic. Okay, both gases are at same temperature. Okay, fine. It means same temperature means kinetic energy of helium will be equal to the kinetic energy of neon. That is what we have discussed in the above part. Okay, now read the question. It is asking you the average speed of helium atom to the neon atom. Now kinetic energy, simply I can write half mass of helium times velocity, or the speed of helium square times half mass of neon times speed of neon square. So this gets cancelled. Mass of helium, let us take the molar mass. So velocity of helium or the speed of helium times this is 20 speed of neon square. So the ratio of V square of helium upon V square of neon is 20 by 4, which is 1 times 5. So taking square root on both the sides, so the ratio comes out to be the root 5:1, which is option B is the right answer. Okay. So this is, you have to read the question very carefully. In this above part, it is asking for kinetic energy, which is constant at the same temperature. But here also the same temperature, but the question is asking for the average speed. Okay. So I hope the questions 1 to 32 is clear now. If you have any doubt, you can comment below. Also, if you want to excel your exam preparation with me, for any one-to-one tutorials or any weekly online classes you want, or any doubt session for any particular topic, you can contact me on the given description below or in my WhatsApp number. Okay. So thanks for the video. Watching this video, please share with your friends so that it can reaches to the masses. Thank you and keep learning.